We've been talking about special quadrilaterals, and our final two are going to be kites and trapezoids. A kite is a quadrilateral with two pairs of consecutive sides that are congruent and no pairs of opposite sides congruent. So it's going to have two sides that are congruent on one side of it and two sides on the other side. They're going to be consecutive, means they're going to be touching. If all four sides are congruent, well, then we have a rhombus. A trapezoid is a quadrilateral with exactly one pair of parallel sides. It does not have to have any sides congruent. It must just have one pair of parallel sides. An isosceles trapezoid is a trapezoid with congruent legs, meaning its legs are going to be equal. Now the bases are the sides that are parallel, and the legs are the sides that are not parallel. A midsegment, finally, a midsegment of a trapezoid is a segment that joins the midpoints of the leg. So if you look at our diagram, the midsegment joins the midpoints of the two legs. So I know the top and the bottom are the base because they're parallel, and the midsegment will go from one leg to the other leg. Now we have a theorem about kites, and it says that if a quadrilateral is a kite, then its diagonals are perpendicular. It means its diagonals hit at a 90-degree angle. We have some theorems also about trapezoids. The first one says that if a quadrilateral is an isosceles trapezoid, meaning its legs are congruent, then each pair of base angles is also congruent. So if the legs of the trapezoid are congruent, the base angles, these two are base angles and these two are base angles, are congruent. Theorem 6.14 or 614 says if a quadrilateral is an isosceles trapezoid, so again, the legs have to be congruent, then its diagonals are congruent. So if the legs are congruent, the diagonals, so AC and BD, are also going to be congruent. And finally, theorem 6.15 says if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is the average of the lengths of the bases. And there's a lot of information, so let's pull that apart. So if we have a midsegment, which is Z, it is going to be parallel to both X and Y. It's also going to be the average of X and Y. So X plus Y divided by 2, it's how we find the average, is going to be equal to Z. So let's look at some examples. Find the measures of angles 1, 2, and 3. Well, angle 1, because I know that the diagonals of a kite are perpendicular, angle 1 is going to be 90 degrees. Angle 2 is part of a triangle. And angle 1 plus 52 plus 2 has to give me 180. Well, 52 and 1 is 90, so 180 minus the sum of 52 and 90 is 38. Angle 2 is going to be 38. Angle 3 is going to be 52. It's going to be the same as the angle it is adjacent to, because we could prove similar triangles based on the information that we have. So we know that 3 and angle 52 are going to be congruent. So we have 90, 38, and 52 for our angles. Find the length of XY. Well, XY, and I apologize it's not labeled, XY is this middle leg right here. XY is going to be the average of BC and AD. So we're going to do a little bit of algebra here, but we're going to say 10 plus 8x minus 12 divided by 2 has to give me xy, which is 2x plus 11. I know that's a lot, so take a second and process that. Now we just need to solve the equation. Let's get rid of the fraction by multiplying the entire equation by 2. So we get 10 plus 8x minus 12 equals 4x plus 22. Each of these were multiplied by 2. Combine like terms, so we get negative 2 plus 8x equals 4x plus 22. Get variables to the same side, so negative 2 plus 4x equals 22. Cancel the constant, 4x is 24, and cancel the coefficient, x is going to be 6. So if we're going to actually find the length of xy, we need to plug that back in. So 2 times x plus 11 is the length of xy, so 2 times 6 plus 11, 12 plus 11, xy is going to be 23. Now, I want you to try these two examples. They're very similar to the last two, so if you need to go back and look at them, check out the other examples before you move on. Also, again, xy is this middle line, and I apologize for it not being labeled. So find the measures of angles 1, 2, and 3, and find the value of xy. Angle 1, again, is going to be 90. Angle 2 is going to be 54 degrees, and angle 3 is going to be 36. Finding the measure of xy, again, we're going to set up our equation similar to the last one. 4x minus 10 plus 8 divided by 2 is going to give me x plus 2. And you can see the steps I took to solve it. You get x equals 3. Take a second and read through the steps. And then to find xy, we plug it back in. 3 plus 2 is 5. xy is going to be 5. And that's the end of our quadrilaterals and polygons unit. Bring any questions you have to class.